somewhere in a data center that nobody's allowed to name, a machine stopped translating and started listening. That is the sentence 3 people in a secured briefing room have not been able to say out loud for 6 days. Not because they were ordered into silence, because none of them could find the words to describe what they were looking at. A signal, not noise, not static, not the familiar hiss of Jupiter's magnetosphere screaming across 50 years of recorded data. Something with structure, something with intention. And for the first time in the history of planetary science, an artificial intelligence built to translate human languages was pointed at a frequency nobody expected it to understand. And it did. That number alone should stop you. Twice. Not almost as much. Twice the water, sealed under 20 kilometers of ice, kept liquid not by sunlight, which barely reaches it, but by the relentless gravitational stress of Jupiter itself, flexing the moon like a fist closing and opening over and over for 4.5 billion years. That flexing generates heat. That heat keeps an entire hidden ocean from freezing solid. And where there is heat, water, and time on that scale, the conversation among scientists stops being about if something could live there and starts being about what already might. But here's where it gets worse. In every real Europa mission proposal, Europa Clipper, the JUICE probe, the landers still sitting in design documents, one obstacle keeps appearing in briefing after briefing. And it isn't a lack of funding. It's radiation. Jupiter's magnetic field is so violently strong that it traps and accelerates charged particles into a radiation belt that would kill an unshielded human in minutes and destroy unprotected electronics in hours. Every camera, every antenna, every sensor sent near Europa has to be built like a bunker. Think about what that means. We are sending machines into one of the most hostile electromagnetic environments in the solar system, wrapping them in vault-grade shielding just to get close enough to take a picture of ice. And still, mission after mission, engineers report anomalies they can't fully explain. Sensor drift, unexpected data spikes, brief periods where instrumentation behaves as if it's picking up interference from something with structure, not chaos. Officially, every one of those anomalies gets filed under radiation noise. Unofficially, according to people who have worked adjacent to these missions, that explanation stopped satisfying everyone a long time ago. Now add the AI into the picture, because this is where the story stops being about ice and starts being about intelligence, the artificial kind. In the last 2 years, language model systems originally built for entirely different purposes, translating human speech, decoding ancient scripts, finding patterns in radio astronomy, data too subtle for the human eye, have been quietly repurposed by research teams to do something audacious. Feed them raw signal data from deep space and ask a simple question. Is there a pattern here that resembles language in the broadest mathematical sense? Not English, not any human tongue, structure, repetition with variation, information density that exceeds what randomness should produce. This is not science fiction anymore. This is exactly the kind of task modern AI systems are disturbingly good at, finding the needle of order inside an ocean of noise faster and more precisely than any human analyst ever could. And that capability is exactly what makes what allegedly happened next so difficult to dismiss. According to individuals who claim direct knowledge of a joint research effort, one that blended a planetary radio astronomy team with a private AI lab testing signal pattern recognition, a recorded burst of electromagnetic activity picked up near Europa's trailing hemisphere was run through a translation pattern model almost as a formality. Nobody expected results. You run the test because that's the protocol, not because you think ice makes conversation. And then the model didn't just detect structure. It began assigning probability weights to segments of the signal the way it would to fragments of an unknown human language, flagging repeated symbol clusters, timing patterns, even something resembling syntax. Read that again. Not a sound wave interpreted as pretty. A pattern-matching confidence score, the same kind of output the system gives when it's parsing a genuinely structured language, applied to a signal bouncing off, or possibly emerging from beneath, the ice of a moon 400 million miles away. This is not chaos. This is, if the accounts are accurate, exactly what structure looks like before anyone dares to call it a message. And this is where everything changes, because the moment a result like that exists, it stops being a scientific curiosity and starts being a problem of power. Whoever holds verified proof of structured signals from another world does not just own a discovery, they own leverage. Space agencies, private aerospace companies, and at least 3 national governments have invested staggering sums into the race to reach Europa first. Not because ice is romantic, but because whoever gets there first writes the terms of everything that follows: ownership of data, control of the narrative, the right to decide what the public is told and when and how. Anyone who has watched how nations behave around resource discoveries on Earth, oil fields, rare earth deposits, contested waters, already understands the instinct. Now imagine that instinct applied not to oil, but to the single most consequential discovery a civilization could make. The instinct to control does not disappear because the stakes are cosmic. It intensifies. What most people are not seeing is how quietly this kind of information can be managed once it starts making people nervous. It rarely happens through dramatic cover-ups with men in dark suits erasing hard drives. It happens through delay. Through review boards that take 18 months to approve a paper that should take 6. Through funding suddenly redirected toward recalibration of instruments that were working fine. Through researchers who once gave enthusiastic interviews to science journalists and now, without explanation, decline every request. That pattern, not proof, but pattern, is what has fueled the theory now spreading in specialist forums and encrypted research group chats that something changed inside the Europa research community roughly 6 months ago. And it changed all at once across multiple institutions that officially have no communication with each other. The real story, if there is one buried under the speculation, is not necessarily that scientists found aliens. It's stranger than that, and arguably more unsettling. It's the possibility that they found something they cannot yet classify, and classification is the entire foundation modern science stands on. A scientist can announce a discovery. A scientist can announce an anomaly. What a scientist struggles to do, institutionally and professionally, is announce something that fits neither category, something that behaves like communication but cannot yet be proven to originate from intelligence, and cannot be dismissed as coincidence either. Careers are built on being right. Careers are destroyed by being spectacularly publicly wrong about the biggest claim imaginable. That fear alone, without any conspiracy at all, is enough to explain silence. But silence born of caution and silence born of instruction look identical from the outside, and that is exactly the kind of ambiguity that keeps a story like this alive far longer than a simple denial ever could. Let's slow down and look at what actually makes Europa different from every other signal story that has burned out in a week of internet hype. This is not a random blip from a radio telescope scanning a random patch of sky, the kind of thing that happens dozens of times a year and gets explained within days as a satellite, a microwave leak, or a misconfigured receiver. Europa is a specific, scientifically pre-identified candidate for hosting life, ranked among the top handful of locations in the entire solar system by the very agencies now sending hardware toward it. It has liquid water. It has a heat source. It has organic chemistry building blocks detected in its plumes, the geysers of water vapor that occasionally erupt from cracks in its ice, discovered years ago by the Hubble Space Telescope and later scrutinized further by Webb. Every ingredient scientists use to argue a place is worth checking for life is already present on Europa, confirmed, published, peer-reviewed, sitting in the open literature for anyone to read. So when a claim of anomalous signal structure attaches itself to a location that already meets every serious scientific criterion for potential habitability, it does not get the easy dismissal that a random deep space blip gets. It gets taken seriously enough to be investigated quietly. And investigated quietly is precisely the space where rumors of suppression are born, whether or not suppression is actually happening. Think about what that means for the people actually running these missions. The Europa Clipper spacecraft, already in transit, was never designed or funded to search for signals. It was built to study the ice shell's thickness, map the moon's surface chemistry, and characterize the ocean's potential habitability through indirect measurement, gravity, magnetic fields, a spectral analysis of the surface. It carries no dedicated signal detection instrument for the simple reason that, officially, nobody expected to need one. If informal reports of anomalous readings are accurate, that omission becomes one of the more uncomfortable footnotes in the mission's history. A spacecraft built to study a silent ocean, now approaching a moon that some believe is not silent at all, with no formal tool on board to properly investigate it. Whether that's a genuine oversight born of scientific caution, or evidence that the anomaly wasn't taken seriously until after the spacecraft had already launched, is a question nobody in an official capacity has been willing to answer on the record. And here is the part of this story that turns it from strange into genuinely consequential. Artificial intelligence is no longer a passive tool in space science. It has become an active interpreter, and interpreters hold power that raw instruments never did. A telescope simply records. It does not judge, does not weigh probability, does not decide what counts as meaningful versus what counts as noise. But a modern AI system built for pattern recognition does exactly that, constantly, at a scale and speed no human review board can fully audit in real time. When that system flags something as structured rather than random, it is making a judgment call embedded deep inside layers of statistical weighting that even its own developers cannot always fully explain. The well-known black box problem that has haunted machine learning for a decade. That means the first entity to potentially recognize intelligent structure in a signal from another world might not be a human scientist at all. It might be a machine, quietly inside a server rack, generating a confidence score that a human then has to decide whether to believe. That is the power shift nobody prepared for. For centuries, contact with something beyond Earth, real or imagined, was always framed as a human moment, a human ear pressed to a radio dish, a human eye squinting at a photographic plate. Now, if any of this is true, the first hearing of a possible signal from another world may have happened inside a neural network, translated into a probability distribution before a single human being was even in the room. That reframes everything about how humanity might actually encounter first contact, if that is ever what this turns out to be. Not as a dramatic broadcast moment shared instantly with the world, but as a quiet flag inside a dataset, sitting in a queue, waiting for someone with the authority to decide what happens next, and having every incentive in the world to think very, very carefully before they do. Any hint, even an unverified one, will permit that a signal of unknown origin might exist near a target moon changes the calculus for every stakeholder involved. Funding bodies start asking different questions. Competing national space programs accelerate their own parallel investigations, sometimes without public announcement, because being second to confirm a historic discovery carries almost as much reputational cost as never attempting it at all. Private aerospace companies, some of them now wealthier and more agile than entire national agencies, watch these developments closely, aware that being positioned at the center of the biggest scientific story in human history is worth more than almost any contract they could sign. In an environment like that, incentives to control information tighten instinctively, even without a single coordinated decision to suppress anything. Everyone protecting their own position, independently, can produce something that looks exactly like an orchestrated silence without there needing to be one at all. But here's where it gets worse again, because the silence itself has started generating its own momentum. Once researchers stop giving interviews, once conference panels quietly get rescheduled, once previously accessible datasets get labeled under review instead of published openly, the absence of information becomes its own kind of evidence in the public imagination, whether or not that absence is justified. This is the paradox institutions rarely account for. Silence intended to protect scientific rigor and prevent premature, sensational claims often produces the opposite effect. It fuels exactly the sensationalism it was trying to avoid, because human curiosity does not tolerate a vacuum. If the truth is complicated, ambiguous, and genuinely uncertain, which, if any of this is real, it almost certainly is, silence guarantees that speculation will fill the space instead, and speculation is rarely more restrained than the truth it replaces. So where does this actually leave us? Not with confirmation, not with proof. What exists, based on everything that can be reasonably assembled from public Europa science and the pattern of unverified claims circulating about anomalous signal analysis, is a genuinely uncomfortable overlap of three real things. A moon that legitimately meets the scientific criteria for potential habitability, and they do not prove a message. But they do prove that if something like this were ever going to happen, a signal, an anomaly, an AI flagging structure where structure shouldn't exist, Europa is exactly the kind of place. And this is exactly the kind of moment in technological history where it would happen first, and where the people who found it would have every reason imaginable to move slowly, carefully, and quietly before saying a single word to the public. And that is the part that should sit with you longer than any headline. Not the certainty of an answer, but the uncomfortable shape of the question itself. What does a species do the moment it suspects, even faintly, that it is not alone, and does not yet have proof strong enough to say so out loud without risking its own credibility forever? Does it rush to confirm at the cost of being wrong in front of the entire world? Or does it wait, cautious and quiet, gathering more data, running more models, letting a machine keep listening long after the humans have gone home for the night? Somewhere beneath 20 kilometers of ice, an ocean has been moving in silence for longer than humanity has existed. Whether anything inside it is moving with intention, or whether every pattern flagged so far is simply the universe's staggering capacity to look meaningful without meaning anything at all, remains the one question nobody, not the scientists, not the machines, not the institutions guarding their data, has been willing or able to answer yet. And until someone does, the silence itself may be the loudest signal of all.